Welcome. In this video, I'll be showing you how to solve problems related to the topic of ions and salts. Most of the methods used in this video were presented in the video on the topic of ions and salts, which can be found in the icon in the top right corner of the screen. Ions and salts is a topic you'll see a lot throughout your time working with chemistry if you have it on more than a basic level. It will appear in other subjects such as equilibrium, acids and bases, solutions, and many more. However, you probably won't see a lot of ions and salts only focus problems. Therefore, in order to make your work easier in these other subjects, you can help yourself by remembering the core principle in regards to working with ions and salts. Salts are neutrally charged compounds consisting of ions which are charged. When a salt is put into water, it will either dissolve or not. If the salts are dissolved, it will split into the ions it's made of. Ions in their dissolved state may react with other chemicals, potentially creating other solid chemicals. A solution may become saturated if too much salt or other soluble substance is added, which means that no more salt can be dissolved. For further information, you can watch the video mentioned in the intro on the topic of ions and salts, which can be found in the iCard and the description down below. In our first example, we have calcium ions reacting with chloride ions to create calcium chloride. We now must find what ratio calcium and chloride will be present in calcium chloride. Doing so will also reveal the reaction equation, which will be put in the top right corner of the screen and updated as we go along to increase clarification. Firstly, we will write the ions as if they are in the same salt but kept their charges. The first step is to check if the charges are the same, ignoring the plus and minus. We can see that 2 and 1 are not the same number. We now move on to the second step. In the second step, we use what's known as the crisscross method. This is done by taking the charge of the cation, removing the plus and placing it at the bottom right of the anion. We do the same for the anion, but since we have a charge of 1, we just remove it. We now have the formula of calcium chloride, and if we check, we can see that the charges cancel each other out, which means that the salt is neutrally charged. For our second example, we have beryllium ions reacting with sulfate ions to create the salt beryllium sulfate. Like last time, the first step is to check if the charges are the same, ignoring the plus and minus, and in this case we can see that they are. This means that we can simply remove the charge and we now have a neutral salt since the charges cancel each other out, which means we have found the salt's chemical formula. For our third example, we have iron-free reacting with sulfide to create iron-free sulfide. Now, once again, we firstly write down the ions as if they are in the same salt or kept their charge. Then we check if the charge is the same, ignoring the plus and minus, and as we can see, 2 and 3 are not the same number. We now move on to the second step, which means we will now be using the crisscross method. This is done by moving the charge of the cation, removing the plus and placing it at the bottom right of the anion. We then do the same for the anion, and we now have the formula of iron-free sulfide, and if we check, we can see that the charges cancel each other out, which means that the salt is neutrally charged. In this problem, we dissolve zinc chloride and sodium carbonate and have to find out which salts form from our mixing. The first step is to write down what ions we get. We don't have to check if the salts dissolve, as it was just stated in the problem that they will do so. We can then see that we get 1 zinc ion, 2 chloride ions, 2 sodium ions, and 1 carbonate ion. The next step is to then check if the cation from the first salt, i.e. zinc, form an insoluble salt with the anion from the second salt, i.e. carbonate, and we can check the salt solubility chart, and we can see that they will form an insoluble salt. The next step is then to do the same, but for the anion of the first salt, i.e. chloride, and the cation from the second salt, i.e. sodium. And if we check the salt solubility chart again, we can see that they do not form an insoluble salt, but stay in their ion form. We can now then say that we have solved the problem and has formed the new salt of zinc carbonate. In our second problem, we dissolve barium hydroxide and magnesium sulfate, and we must once again find out which salts form from our mixing. The first step is to write down what ions we get. We don't have to check if the salts dissolve, as it's stated in the problem that they will do so. We can then see that we get one barium ion, two hydroxide ions, one magnesium ion, and one sulfate ion. The next step is to then check if the cations from the first salt, i.e. barium, forms an insoluble salt with the anion from the second ion, i.e. sulfate, and if we check the salt solubility chart, we can see that they do form an insoluble salt. The next step is to do the same but for the anion of the first salt, i.e. hydroxide, and the cation from the second salt, i.e. magnesium. And if we check the salt solubility chart, we can see that they do form an insoluble salt. We can now say that we have solved the problem by concluding that we will form barium sulfate and magnesium hydroxide. In our last problem for today, we have an unknown salt consisting of two potassium ions and one chemical X ion, and we have to find the charge of both ions. Firstly, we find the charge of one potassium ion. Since we know potassium in the first primary group of the periodic table, we know it has a charge of +1. Now, since we know that a salt has to be neutrally charged, we can ask ourselves what charge is chemical X required to have in order to cancel out the charge of the two potassium ions, which together have a charge of +2, since 1 times 2 equals 2. This means that chemical X must have a charge of -2, since 2 minus 2 equals 0, which means that the salt is neutrally charged with the charges found. And we have now solved the problem. That's all for today. And as always, feel free to like and subscribe. Feedback, questions, or suggestions down in the comments below. And as always, have a nice day and good luck with your work.